Hello, we're going to cover JUnit testing, and actually we want to take a step back as well as, and we want to test or talk about just general testing philosophy in programming. Then we'll talk about how we do it in Java using the JUnit test framework, and then we'll talk about in VS Code, how do we use VS Code to do JUnit testing in Java. Okay, so the testing philosophy. First off, we just have this mantra. If you haven't tested it yet, it is broken. If you have not tested your code, if you haven't tested out every single line of your code, there could still be a bug. So what we do when we're writing test code, we want to try to achieve, our goal is to try to achieve 100% code coverage. Code coverage is a measurement of how much of your code has been tested so far, and basically you want to cover every single line of every single method of every single class. Now, 100% code coverage does not guarantee that you do not have a bug in your program, but I can also say the kind of the opposite, that without 100% code coverage, you can definitely not claim that your program is bug free. And so the goal is to test everything, but to also test everything automatically, so that with a push of a button, you can repeatedly just test all of your code, and it just reports a very simple pass-fail result. And this kind of leads to the idea of regression testing. Regression testing is this idea that you don't want your code to regress. You don't want your code to take a backward step in terms of functionality. So whenever you make a change, whenever you add a new feature, whenever you try to fix a bug, you make sure that you run all of your tests on it so that you make sure that you haven't broken anything in the debugging or in the bug fixing or the adding of a new feature. And so this regression feature is important. You know, the idea of automatically testing your code every single time you make additions or changes is vitally important. And of course, every time you add new features, of course, you're adding new code, and so you need to add more test code to also test that out. Now, let's just talk about some non-automated testing. Here's a very simple example of a class, two fields, constructor to initialize the two fields, two very simple getters, an add method, and an absolute value function. Very simple class, and it's more just to talk about the concept about testing. So a very simple way of doing it is either within the class itself, or maybe in some other class we create a main, we make the object, we construct the object with interesting information and data, and then we call the different methods as a way of testing, does each of the methods work? And we have an idea of what our answer should be. And so then when we run the program, we can look at the output results and we can verify that it's working. Now, the issue with this methodology is that it's not automated in the sense that when I do press the run button, I have to manually look at the printout and say, oh, is it a 2? Is it a 5? Is it a 7? Is it a 3? And every single time I run the program, I need to kind of make that consideration. So an improvement on it might be, instead of, looking at a 2, 5, 7, 3, I do some sort of equality check where I know what I should get, and when I call the method, I check it to make sure it is that value. And so then in that case, I'm just looking for true, 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 true. Now that makes it easier to look at. I don't have to remember the 2, 5, 7, 3 output. But at the same time, if I have thousands of tests, I don't want to actually be scrolling through my entire test suite to make sure that everything is true. So, that suggests a very easy simplification where I just, I put all of these clauses into one big if statement, and if all of them are passing, then I say we passed, otherwise I say we failed. And we could grow this, and we can, add any number of tests to this. Now, the issue could be in this case that when this does fail, I don't know which one did fail. Now, of course, I could definitely create helper methods to kind of help me with this, to test out whether any of my tests pass or fail, have it print out a message, have it tally up the final result. So I could do this on my own, and definitely in the early days, that's what people would do. They would just improve this method. But because testing is so important, every programming language, I would say, has some sort of what I would call a testing framework. Basically, it's a standard method for writing tests in that particular language. It's a library. It's a library that allows you to do things in a very common way from one project to another project, from one group to another group. We all use the same testing framework. And so this testing framework, it will give you a simple pass-fail result, which is what we want. It will also, when it does fail, it will print out some message saying this is why it failed, this is what test it failed upon. Now, in this JUnit test framework, there are two things we need to do. We need to kind of mark up our methods with what we call annotations. And this is an annotation that we could write right above the method, which marks this method as one of our test cases. We might have other methods, other helper methods, and only certain methods do we want to say is an actual test case. So when we have annotated as such, then the framework will automatically recognize and execute each one of those tests as tests to determine whether our program is passing or failing. Now, on top of that, with any kind of framework, there are methods that are created for you to help you do your work. And so there are what we call assertion methods within this JUnit test framework. These methods make assertions, they make claims. They basically say, is the result of this equal to this, or is the result of this true, or is the result of this false, things like that. And if this assertion method call fails, the test fails. So here's an example. So taking the same math class that I want to test, same concept, this is what I do. I create a new class. This is my test class. It extends this framework. And in below, or below here, you see that I create my object. I initialize it with something interesting. Then I call the method, and I give it the expected value. And this assert equals method is a method belonging to this framework as a way of checking to see whether it's equal to each other. And if, in this case, I have two different assertions here, if either of these assertions fail, then this particular test, this test constructor test, will fail and it will get reported as such. I could have multiple of these tests. I can create as many methods as I want. I just annotate them with this @test annotation. Now, there are many different assertion methods. I show you the assert equals. There's also an assert true, so that if this condition is true, it will pass. I have an assert false, which is saying that I expect this condition to be false. I also have an assert null, which says this object here should be null. And there's, again, many more assertion types, and if you want to look them up, you're welcome to kind of study the documentation. Now, on top of whether or not these two inputs are correct, are equal to each other, I could also put this optional string message here in front of all of these assertions. And so this will be a string message that gets printed out when one of these assertions fails. So let's give it a try. Oh no, before we do that, here's VS Code now. How do I enable Java test in VS Code? First of all, you go to this little test tube and you press that button. Then you will see this, and then you of course press enable Java, and then you will see this menu, and then you select JUnit, and then you're all set. If you, on the previous slide, if you had any red curly bracket lines here saying, oh, I don't know what test case is, or I don't know what assert equals is, going through this step in VS Code will allow it to kind of understand those methods. It will basically import that library automatically for you. And then in VS Code, you might see these little icons here. If you press at the very top here, it will then run every single test within the your class. Or if you just press one of these, it'll just run a singular test, which is kind of nice because sometimes you're just maybe adding a new feature and you created some new test cases just for that. So you want to test that out first, and then after that's working, then you can run everything to make sure that in your regression test, everything is still working. Okay, so actually let's do a quick demo of that in VS Code. So over on the left-hand side, I have my very, very simple math class. And then over here, and actually down below, you could see what I've done here, a very simple way of debugging it where I just run it and then you can see down below, I get my output, and I have to then kind of remember, oh, okay, it should be a 2, it should be a 5, it should be a 7, it should be a 3. So instead, I'll just kind of convert that to this test code over here, where I do the same thing. It's doing the exact same test, but I'm just using the test framework instead, where I call this method, check to see if it's 2, call this method, check to see if it's 5, etc. So let's see what happens when we run it. In this case, it ran and it passed. It just, yeah, that's all it is. Let's actually create a failure to see what happens when you see a failure. Let's change this to 9. So I actually broke my test case actually. And I'll run the whole thing. Okay, so in this case, you could see that it failed here. If I scrolled up here, and then also you could see here that VS Code itself highlights the location. It says, oh, I expected a 9 because that's what I said, but it was actually a 7. So actually then I realized, oh, my test code is messed up. I got to fix my test code. And then I could just rerun this one test. And then I could see that it passed. Okay? So that's the lesson for today. Hopefully that gave you an idea of what this JUnit testing thing is all about.